Alright, so we're going to do another substitution problem, only this one we're going to be working with our rational exponents. So we still have to change it into a quadratic that we can work with, whether that means we're going to have to factor when we solve it, or we are going to go ahead and use the quadratic form. It doesn't matter, but when we look at these equations, we have to look and determine, is this something that I can solve right now, or do I have to do something to it? This is going to be another problem where you're going to have to do something to it. So I'm looking at it, it says x plus 1 to the 2/3 minus x plus 1 to the 1/3 minus 2 equals 0. So we will do substitution. So the easy part, look at your middle term. Your middle term is basically going to tell you what your u is going to equal. Once you square that, that's going to get you your first term. So if my middle term is x plus 1 to the 1/3, that's what I'm going to let u equal. U should equal x plus 1 to the 1/3, which means u squared should equal your x plus 1 to the 2/3. And it's that simple. So we just have to be able to identify what's my middle. If I'm going to use substitution, look at your middle term. If you can square that and get your first variable term, like the other one, it was x squared. If you square that, you get x to the 4th. So you just found out what u is equal to. This one, it's x plus 1 to the 1/3. If I square that, I get x plus 1 to the 2/3. So now our equation becomes x squared minus u minus 2 is equal to 0. So that's pretty simple. That right there, you can solve either factoring or quadratic formula. So that's what I'm going to write. You either factor it, you do quadratic formula, complete the square, whatever. It is a quadratic that you can solve. All right, now this one should be really easy because it is factorable and it's really simple. So I'll draw out the box. U squared on the top left, minus 2 on the bottom right. Those two should add to negative u. So I'm filling out my box. There it is. There's my factors, u minus 2, u plus 1, and that equals 0. Solve in each case. U is equal to 2 and u equals negative 1. And we are not done yet. Remember, you guys still have to solve for x. We replaced x's with u's so we can actually get an equation that we can work with and solve. So on this next page, we're going to go ahead and do all of that substitution stuff. So we know that u is equal to 2 and u is equal to negative 1. Well, guess what? Replace it. Replace what u is equal to. We let u equal x plus 1 to the 1/3. Alright, so now we're going to have to go ahead and replace and solve for our x variable. So our equation is no longer u equals 2, it's x plus 1 to the 1/3 is equal to 2, and x plus 1 to the 1/3 is equal to negative 1. Now once you get here, you are going to start solving. Easiest way is to cube both sides. That's what you have to do. It's to the 1/3 power. That's basically the cube root. If you're going to undo a cube root, you're going to raise it to the 3rd power. You're going to cube it. So cube both sides. So that's what I'm doing right now. When I do that, I end up getting x plus 1 is equal to 8, and x plus 1 is equal to negative 1. Now from there, just keep solving. I get x equals 7, and I end up getting x equals negative 2. Now what I didn't put on the first video is that you need to check. Always check that your answers work. Take the variables that you solve for, x is 7 and x is negative 2, plug it into the original. Check it out. Make sure that it works. If you plug in 7 and you plug in negative 2, they both work. They're both solutions. But remember, on Friday, we went through a couple problems where we solved, got some solutions. We got like x equals 1 and x equals negative 1. They didn't work. None of them worked, so we didn't have any solutions. Or we checked and we solved and we got maybe two answers, but only one of them worked. All right, so you have to check. Always check to make sure that you're solving for variables and the solutions that you get are actual solutions. All right, there are times when they're not going to work, so you always have to double check that stuff. All right, but this was another problem that we had to go ahead and use substitution to go ahead and change into a quadratic to be able to solve.